Hi everyone, I'm Herman, and this is my final project. It's NLP in financial market. To be precise, it's sentiment analysis of stock news. So this is the plan for today. I'll first talk about the methodology, technology, and data sets. And for this project demo, I will use NVIDIA stock. So first, I will retrieve all the NVIDIA stock news from the FinHub, and then I'll talk about the pros and cons of the sentiment analysis models. And then I will show you how to use the sentiment analysis scores, combine it with the stock price from the Yahoo Finance to do stock price forecasting using the reduced model, simple linear regression model, and the mixed models. So this is the problem definition. So as an equity portfolio manager, I must follow a lot of news regarding the all stocks in my portfolio. So in the morning, I usually have to read a lot of news. And you can imagine if I have like stocks in the Asia and also have stocks in US stocks. So it can be a nightmare. So I need a tool to be that is able to summarize all the sentiments of the hundreds of the stock news so that I can make quick judgment whether I should like buy more or sell more or maintain the number of stocks in my portfolio. So before I explain about the methodology, I think I should go back to the Jupyter Notebook and restart the Jupyter Notebooks because it will take a few minutes to run until finish. Okay, so this is my Jupyter Notebook. So I'll run it from the start. Okay, and I'll go to the top. It's still initializing the imports. So this is the place where I would enter the stock ticker. In this case, I'll enter NVDA. Okay, so I'll enter NVDA and it will process it for a few more minutes. So in the meantime, let's go back to the presentation. So this is the methodology. So first, I will retrieve all the NVIDIA stock news from the FinHub from Jan until November 2024. And then I'll utilize the sentiment analysis models from Python like Hugging-Based Finbird, TextBlob, Flare, and Fader. And I'll combine it with the daily stock price from the Yahoo Finance and then apply some functionality from stats models to do stock price forecasting. And on the right, you can see like all the Python packages and the versions that I use for my final project. So from FinHub, I'll be able to retrieve around 1600 NVDA stock news from Jan until November 2024. And by grouping the stock news daily and calculate the average daily sentiment scores, I will eventually get around 228 daily data. And then I'll split this data into trained data set and test data set. For the test data set, I will only use the last 10 daily data. And this is the pros and cons of the different sentiment analysis models. Finbird is the most appropriate for this final project because it is trained for financial domain data and it uses BERT architecture, offering high accuracy and contextual understanding. The cons of Finbird is it requires significant compute resources. Flare is similar to Finbird. It uses transformers and it also requires computational power and it is not trained using the financial domain data. So it's general. TextBlob is a simple basic and sentiment analysis tool and it's very good for smaller data sets. Fader uses a rule-based approach, so it is usually effective for short social media reviews like Twitter reviews. So this is how we do the stock news retrieval from FinHub. So basically, I'll combine all the data into a simple news data frame, which only has 5 columns: date, time, headline, source, summary, and the URL. And then I'll combine the headline and the summary columns into a small variable called combined text. So combined text will contain the headline and the summary of the stock news, and they are really critical. They are very important because they have like the context of the stock news that we want to analyze. And this is how we do the sentiment analysis. So feather and text block return single scores. So for positive sentiments, they will return positive scores. For neutral, they will return zero. And for negative sentiment, they will return negative sentiment. So it's very simple. For Finbird, it will return sentiment and confidence level of the sentiment. So we need to do some score conversion. For the positive sentiment, I'll convert the confidence level into positive score. For negative sentiment, I'll convert the confidence level into negative score. And for neutral sentiment, I'll assign zero as the scores. So this way we can compare the scores of Finberg with those of Feather and TextFlop. For Flare, it's similar to Finberg. So I have to do some score conversions so that we can compare the scores of Flare, Finberg, TextFlop, and Feather on a similar scale. Next, I will combine all the individual sentiment analysis scores into a complete data frame. So currently, all the individual sentiment analysis score range from -1 to 1. So I will want to normalize those scores to 0 to 1 range because it will make our life easier when we do the stock price forecasting. So this slide shows you on the left the average daily sentiment scores, the visualization. So we can see that the sentiment can go increase, can like in uptrend, in downtrend, or in flat trend. Okay, so based on the graph above, sometimes the score of one model could diverge from the others. And on the right, you can see the correlation matrix, and you see that there is no strong relationship among the models there. So I mean, there's no multi-collinearity problem, so which is good, as we will use these scores to do stock price forecasting. And this slide shows you the daily stock price, the visualization of the NVDA. And since we are dealing with time series forecasting, we need to convert the daily stock price into the daily log returns to make it stationary. Okay. And before we do stock price forecasting, I need to do a little more data preparation. So some days have zero news and some days have a lot of news. So for days without news, I will assign a zero sentiment indicator, and I will assign -0.0001 negative values for the sentiment analysis scores, because we cannot have null values when we run regressions. So for the regression models, I will use 7 models. The first one is the base model, which is ARIMA. I will use the auto ARIMA functionality from the PM Darima Python package. And then I'll use the mixed models, which is combination of the log stock returns plus the individual sentiment scores. And then for the final, I'll use the simple regression. Okay. And this is the final result of my analysis. So this slide shows you the stock price forecast of the individual models. So as you can see, the stock prices, the forecast do not follow the actual stock price, because the actual stock price in has like a non-linearity. So for future results, I will do nonlinear model forecasting using SVM, random forest, fully connected RNN, and LSTM. And this is also one of the final analysis in my final project. So it will show us the test root mean square error RMSE comparison for the NVDA stock. So on the left, you can see that model number 2, which is the flare scores sentiment analysis, have the lowest RMSE. But if I run again my notebook for Tesla stock, it will show us that the auto ARIMA is the best model for Tesla. So different sentiment analysis models fit different stocks. It might be due to the problem of the quality of the stock news that I retrieve from the public space from FinHub. But if we want to use it to be more professional, I think we should use the professional services of Bloomberg and Reuters to get proper stock news and a lot more stock news from Bloomberg and Reuters. So before we go to summary, we'll go back to the Jupyter notebook to see if it's finished. And yeah, it's finished. I think so. So this is how I retrieve the NVDA stock news from the FinHub. So I'll retrieve the monthly data, January, February, March, April, and so on. And this is the start of the sentiment analysis. And this is how we do the Finbird sentiment analysis, as I've shown you during the presentation. And this is the sentiment analysis from Fader. And this is the text plot. And this is Flare. Okay. And then this is the correlation matrix that I've shown you in the presentation. And this is the visualization of the daily normalized average sentiment scores for NVDA. And then we do the stock price retrieval from Yahoo Finance. And first, this is the daily stock price, and then we convert it to log returns to make it stationary. And then we do the ARIMA stock price forecasting. So this is the start of the ARIMA analysis. We use the auto ARIMA Python package. And then this is where I do the stock price forecasting using the mixed models and the simple linear regression model. And finally, this is how we compute the test RMSE and the plots of the stock price forecast. So with that, let's go back to the presentation. So in summary, sentiment analysis really help a lot for investment professionals like me, because it will reduce the amount of required reading time from reading so many news and just like see a simple graph showing like whether the sentiment are increasing or decreasing or in flat trend. Okay. And for financial market, Finbird is the preferred tool as it is trained for finance domain. So the individual sentiment analysis scores, if combined with the appropriate forecasting methods, I think they will be able to forecast stock price quite accurately for shorter period, right? And no one model fits all, so we should use our wise judgment. And again, the effectiveness of this project is limited by the available stock news in the free public space. To be more professional, we should use the stock news from Bloomberg and or Reuters. So for future research, I'll do I'll test the nonlinear models such as FEM, random forest, RMN, and STM to do the stock price forecasting. So in the end, this is the end of my final project. So hopefully you also learn some interesting facts regarding sentiment analysis and its application in the finance domain. Thank you again for this class. I've learned a lot, and thank you very much. Thank you. Bye.